Hi, so this is new. Welcome to the first ever Workbench Wednesdays, which is a kind of a new series I thought we could do here where we just sit down, talk a little bit, and this is mostly unedited, unscripted. I just let you know what's going on, and you can say hi, let me know what kind of things you want to learn, what you want to see more of, and we can just hang out and chat. Alright, so the reason that I'm making this video today is that I had a failed project, and I wanted to tell you about it because I think it's an interesting sort of like teachable moment. Here you see that circuit that I built, and this is a project that failed. And those of you that follow me on Twitter have already seen this. This was supposed to be a real-time clock tutorial video. And what a real-time clock does is actually really nice. It's a little circuit that you can plug in, a little integrated circuit right here. And what it does is, if you disconnect the main power, this actually draws power from a small coin cell battery that you would put here. That's where this empty space is right now. There would be a battery. If you disconnect the main power, this will keep the time. And this is really convenient because for those of you that have seen my binary clock video, binary clock sitting right up there, you know that if you disconnect the power from that one, what happens is it just forgets about the time, and when you start it back up again, it starts at midnight, which is a little bit annoying because, you know, you have to reset the time every single time manually. Now with the real-time clock, you wouldn't have to do this, which is why I thought it would be a really nice little tutorial. Now, I wanted to change things up a little bit, so I didn't want to use the same, 7-segment displays that I used in the scrolling text display. I wanted to use different ones. So I thought, let's use green ones, let's use bigger ones. These are actually 1 inch. Now there's a problem in hindsight. The CD4094 shift registers are actually, well, they are shift registers. They are not drivers. And when I looked at the datasheet, I actually realized they actually can only supply 1 to 2 milliamps of current. But those displays, because they're a bit bigger, they need 15 to 20 milliamps to be fully illuminated. So let me show you what happens when you turn the circuit on and how dim it actually is. So here you see it. So you might think this is actually not that bad. And, depending on my mood, sometimes I look at this, I'm like, man, it's not too bad. Sometimes I think, oh, this is really bad. I think objectively, if you hold it far away, it's very easy to see that this is just not bright enough. And yeah, so I'm not happy with this. But in these moments, what can you do? So I was thinking either let's find different displays that actually kind of work with these registers, because those red ones up there, for example, they work really well in the scrolling text display. But then I started thinking that I would actually just be treating the symptoms of the problem and not the actual cause of the problem. The cause of the problem is that CD4094 shift registers are okay as LED drivers if you're driving very small LEDs that don't have a lot of brightness, that don't take a lot of current, then they're kind of okay. But in principle, it's just a bad idea to drive bigger LEDs with this. So instead of masking the problem and just kind of working around it, I decided to find a better solution. And so I did some digging, and I found there is a different IC that's called the, I have a paper here, it's called the TLC5916. And that's made by Texas Instruments, and it's also a shift register, just like the CD4094, but it actually has an additional driver stage that allows you to drive LEDs, and it can actually adjust the current with just one external resistor. So this is a super versatile little driver IC that is just very nice to know about and to use in projects. So I thought, okay, let's pause this little tutorial for a while, and I will order those ICs today, the TLC chip today. And when it gets here, I will focus on writing a tutorial on this chip because I think it's just very nice to see how that chip works, what is similar to the CD4094 and what is different, and just how this chip makes your life better when dealing with 7-segment LED displays like those ones right here. There is something else I wanted to show you, and that is this thing right here. This is an RCA Stratoscope. And what this thing used to do, and this is a device I believe from the 1970s, it used to be a tuner somehow to receive terrestrial television. So just regular old-fashioned television over these antennas here, and you could fine-tune the frequency with this knob here. And when I saw this on the flea market, I just thought this looks so cool, I have to get this. This was like $15. So I'll be using this in a future project, and it's going to be some sort of a clock or something, so stay tuned for this one. I'm excited for this project. Alright, so I think this kind of wraps it up for today's Workbench Wednesday. Let me know what you think of this kind of video series. Drop by in the comments, introduce yourself, say hello, I'll get back to you. Let me know what kind of things you want to learn, what kind of things you like about the previous tutorials, projects, what kind of things you want to see more of, what kind of things you didn't like, what I can work on, what I can improve, and let's start a conversation. So I'm excited to hear back from you. Thank you so much for watching, and I'll see you next time.